Welcome to solverfy, the place where learning becomes simple. If you're struggling with homework, assignment, or doubt in subjects, don't worry, you are in the right place.
A quick sketch of the system of basically a free body diagram, and we can apply then Newton's second law to the x and y directions. Mind you, we have set new Cartesian axes in order to make this problem a bit easier to solve. And so in the x direction, we have t minus mg sine of theta equaling 0. And then for the y-axis, we have the force normal minus mg cosine of theta equaling 0. And so for part A, we're going to solve for the first equation, solve for the tension. This will be equaling mg sine of theta. And to solve, this would be the mass, the mass to be 8.5 kilograms multiplied by 9.8 meters per second squared multiplied by sine of 30 degrees. So the tension is equaling 42 newtons. This would be our answer for part A. For part B, then, we want to find the normal force. So the normal force would simply be equaling to mg cosine of theta. So this would be equaling to 8.5 kilograms multiplied by 9.8 meters per second squared multiplied by cosine of 30 degrees. And this is giving us 72 newtons. So this would be our answer for part B. And then finally, for part C, when the cord is cut now, it no longer exerts a force on the block. And so we can say that then the tension force is eliminated in this case. And the block isn't at rest anymore. So we can say that negative mg sine of theta, which is actually pointing down the incline, this is going to be equaling to mass times the acceleration. Of course, the mass cancels out, and we have that the acceleration is going to be equaling to negative 9.8 meters per second squared sine of 30 degrees. And this is giving us negative 4.9 meters per second squared. So this would be your answer for part C. The fact that it is negative means that it's going to go down the incline. That is the end of the solution. Thank you for watching.